Okay, moving on to 10.1, day 2. Let's see, 10.1, day 2. Alright, 3 new shapes today that we're going to work with for area. We've got our rhombus. And if you remember, a rhombus was a parallelogram with 4 equal sides. Kind of looks like a diamond. And then we're going to have the kite. If you remember kite, it was 2 sets of consecutive congruent sides, not a parallelogram. And we are going to work with the trapezoid. And a trapezoid, if you remember, had 1 set of parallel sides and 1 set of non-parallel sides. So like here, these 2 are parallel. These 2 are not parallel. They may or may not be the same length. If they are the same length, that was an isosceles trapezoid. If they're different in length, then it's not isosceles. But the 2 parallel sides were your bases. Base 1 and base 2. Your height is always the distance between the bases, perpendicular distance. Again, that can come from one of the corners and make a right angle with the opposite side, or it could be right in the middle here. Either way, height's the same, just has to be perpendicular distance between the bases. Now, the rhombus and kite, okay, let me get this formula out of the way. The area of a trapezoid, a little bit more complicated. You have to add the 2 base lengths together. Add those together, multiply by the height. Then at this point you can either times by 1/2 or divide by 2, whichever one you like. I always like to divide by 2. So add the bases together, base 1 plus base 2, that sum, times by the height, divide by 2. The kite and the rhombus, the formula is the same. And the formula refers back to the diagonal lengths. So if you remember, the diagonal lengths connect these opposite vertices. So that's a diagonal. And then from this vertex to this vertex is the second diagonal. And those will made a right angle. Same thing on the rhombus. Diagonal 1. Diagonal 2, and those are perpendicular also. So the formula for the rhombus and the kite is just diagonal 1 times diagonal 2, and again, cut in half. D1 times D2 cut in half. So, I put those on my card already. Put the rhombus and kite in one spot. Instead, talking about diagonals here, D1 times D2 divided by 2. And the trapezoid, I drew the 1 in the notes here. I forgot to mention, if you rotate the trapezoid, this side may or may not be perpendicular, but again, the bases are always parallel, so they could be up and down like this, and your height is the perpendicular distance between them. And then put the formula here. So you can do that later. We're just going to jump right into our examples. Let's see. Find D2 in the kite. So we've got a kite. Here's what I know. This diagonal is 14, and the area is given as 238 square inches. Can you find the missing diagonal? Alright, so kite, formula first, before you even substitute anything in. Okay, I can use substitution, put 238 in for the area. D1, it doesn't matter, one of them is 14. Times by the other diagonal, divide by 2. at this point you have options. You could reduce your 14 and 2 right now and make this 7, or you can multiply by 2 on both sides and then divide by 14. So just don't break the rules of algebra and you'll end up with the right answer. I'm going to choose to, because just in case that was odd, you wouldn't be able to reduce, I'm going to multiply by 2 on both sides. So on the left, I get something I can't do in my head. 238 times 2, 476. 2's cancel over here, left with 14d, divide by 14, 34. So the other diagonal is 34. Number 2. Let's go with a rhombus that has a diagonal of 8x plus 7, and then a second diagonal of 14x minus 6. Give the area in terms of x. Okay, well, this just looks like some algebra. So area formula is d1 times d2 divided by 2. Setting this up, d1, 8x plus 7, 14x minus 3, or excuse me, minus 14x minus 6, and then divide by 2. I think I'm going to make it a 1/2 in this case. I don't want that fraction there. So I've got 3 things multiplied here. I'm going to choose to wait on this. I can only do 2 things, or multiply 2 things at one time, so I'll keep the 1/2. Remember from Algebra 1 how to multiply a binomial times a binomial. The correct way to do that is to use FOIL. So we will multiply 8x times 14x. That will be 112x squared. That's a minus 6 there, so 8x times the minus 6 will give us a minus 48x. 7 times 14 is a 98x. And then we will have a minus whatever 7 times 42. Thought it was going to be challenging. Okay, I'm going to combine the x's here. Negative 48 plus 98 leaves us with a positive 50x in the middle. Now I'm going to distribute the 1/2. So half of 112 is 56x squared. Half of that positive 50 is a 25x. And then half of that negative 42 is a negative 21. And there's the area. Just some algebra there. Let's go number 3. This will be our most challenging one of the notes. Here's our kite. And we're trying to find the area of the kite, and this is what we know. This side is 29, this one's 35, and let's get rid of that dumb thing. And what else do we got? Oh, this from the intersection down is 28. Okay, so in order to get the area, our goal is to find the area, I need to know both diagonals so I can multiply them and then cut that in half. Well, if you look, I don't know anything about the diagonals right now, but the one thing I do know is that they are perpendicular, always on a kite. So now, if I look at this triangle here, I've got the 35, I've got the 28, I can set up Pythagorean theorem to find this piece here. And once I have this piece, this side is going to be equal, because you can see these triangles are the same, congruent. And then, so that'll give us diagonal 1. Then, once I know this one, I'll be able to do Pythagorean theorem up here and find this piece. And once I know that, that will allow me to get this diagonal length. So it's a three-parter, where two parts are Pythagorean theorem, and then the formula for area. So let's start down here. Leg squared plus leg squared equals hypotenuse squared. And again, this doesn't have to be a lot of work once you set it up. Now if you grab the calculator, you know the algebra here. Okay, I didn't even go anywhere. Where'd my calculator run off to? Oh, here it is. Couldn't find it. Alright, clear. So I'm going to go 35 squared, subtract 28 squared. Calculator does the squaring before the subtracting. It has that order of operations, which is nice. And then square root that answer, 21. So this x value is 21. So that means this side is 21. And now I'll do a Pythagorean theorem up here. So leg squared plus leg squared equals hypotenuse squared. So 21 squared plus y squared equals 29 squared. And then now I'll calculator work. 29 squared, subtract 21 squared. And square root that, should be 20. So now I can see, it doesn't matter which one I call diagonal 1 or 2. If I go across for diagonal 1, that's going to be 42, adding the two 21s together. And then vertically, my diagonal total distance will be 20 plus 28 for a 48. So 42 times 48, divide by 2, 1,008 for a total area. Number 4, just a lot of examples, lots of algebra, not on summer vacation yet. We haven't done much with the old trapezoid. Parallel, just in case they don't look like it, we'll go 28, 18. The area is 253. Can you work backwards and find the height? So again, start with the formula, then use substitution. Formula is crucial. So for a trapezoid, if I look back on my sheet, I will see b1 plus b2 in parentheses, times by the height, divide by 2. So substitution, in place of a, I can substitute in the 253. And in place of both bases, I can put these two numbers, and because they're added, it doesn't matter which is which. Okay, so now we work backwards. Well, first, order of operations, I'm going to add these two together first. 28 plus 18, that's 46. H divided by 2 is 253. And then now I'm going to times by 2 on both sides to cancel my 2 out. .253 times 2, 506 equals 46H. Dividing, get a height of 11. Okay, so just practice. Good practice. Do another one of these where you're finding the base. That's the tougher of the two. I think I'll start a new page. Number 5. Trap. Missing base, that's a B. 16, 12, area 174. Find that missing base. Maybe I'll keep it a B. It doesn't look too much like a 6. So, formula first. Trapezoid. B1 plus B2 times H divided by 2. So area is 174. I can substitute in a 16, and I have to leave the other one as a b. The height, I can substitute the 12. All right. There's lots of correct algebraic ways to move from here, and there's some incorrect ones. I'd like to eliminate that fraction, because fractions tend to stump students the most. So I'm going to multiply by 2 on both sides. You could choose to just reduce right here and get rid of the fraction. That would be legal also. But if that's odd, then you wouldn't be able to do that, and it would make it a little tougher. So, well, you would. You just have a decimal up there. But I'm just going to continue with multiplying by 2 to cancel that fraction out. Then it's gone. You don't have to worry about it anymore. 348 equals 16 plus b in parentheses times 12. Now at this point you have options. It would be legal to divide by 12 on both sides and just cancel over here, or you can distribute the 12 and get rid of the parentheses. I'm thinking that's what might make you feel best, is distributing. Less chance for error there. 16 times 12 is 192 plus 12b. And now it's at a point where you should not be afraid of it anymore, if you ever were afraid of it. $156 equals 12b. Divide by 12. So the other base was 13. Okay, I think we will go with one more. Let's go. We've got a rhombus. One of the diagonals is 3x. The area is 12xy. Can you find the other diagonal? All right, formula first, substitution, algebra. So, formula first. D1 times D2, divide by 2. Now substitution. In place of D1, I can put in a 3x. I can't substitute for D2, I'm just going to keep it as D. And then in place of area, I can put 12xy. And then that divide by 2 is still there. And now our goal is to solve for the diagonal, not the x. So we'll have x and y in our answer. So again, fractions, get rid of it. Easy first step, times by 2. Cancels that out. On the left, gone. Over here, 24xy equals 3x times d. Divide by the 3x because you want to solve for the d. So over here, what's going to find each other? The 24 will divide by 3 and leave you with 8. The x's are going to cancel each other out, and you still have the y hanging around. So that missing diagonal is 8y. So lots of algebra in this section. If you have troubles with it, come on the Google Meet, and we'll get all that cleared up. So that ends 10-1.